Hey guys, what's up? In our previous video, we talked about placeholders, we talked about variables, we talked about what is feed dictionary and how to get the output of the variable using session. In this tutorial, I'm going to talk about how to use the operation, Tensorflow operations, and if we get time, we'll talk about session. So let's start with operations. To understand operation, let's create a neural network. A simple layer transition means we have this, where is that? We have this design. So here all these are one input placeholder which has 3 rows, 1 column. This is another, this one is the variables because we are not specifying the value of this one. It will be the value of this will be set by the network when we train it, and here we have one output. It will be another placeholder. Let's first create the variables and placeholders, and then we will do this linking, how to link the input this one node to another. So I'm deleting all this, and only one input is required because we are providing all the values in one input using the matrix format. So it will be input, it will be only input, float, shape 3, that's fine. And next one is to get this output of this network, this hidden layer. We need to multiply the input nodes with some uh, weights. For example, this hidden node has input from this one, input from this one, this one, which has the weight of 0.2, this one has the weight of 0.8, and this one from this one, which has the weight of 0.3. This is just an example. So whenever the value of this hidden node is getting calculated, it's how it is actually calculating the value is, it is taking the value of the input, multiplying it with its weight, and putting it here, and getting the another input and putting it the side, and getting the out another input and putting in another side, and summing the all three together and getting this value. So how it is doing it is, I have this here. So how it is doing is, we have inputs which has some weights, it is multiplying with the input, and second weight is multiplying with the second input and summing them all together and giving you the output of that particular node. So we have the output of the particular node by summing the weighted sum of all this previous layer neurons. These are all I'm going to call them neurons. So we need to create a variable which will hold all these weights. We will have to have a variable which should have 3 cross 3 matrix. So let's create a weight matrix. Weights equals tf dot variable, and this initial value, the first we have to provide the initial value equals tf, and the initial value we are going to provide is, it will be random. So tf dot random, and random will be a normal random, means it will be centered around 0, means it will not be very big or not be very small, so it will be somewhere around 0, like positive side or negative side, but it will be very close to 0. So it will be a good start. so random normal. Now we have to provide the shape of the matrix, shape that we decided 3 cross 3. So 3 for the input, 3 for the output. Okay, another thing is we are only providing two inputs. That is my mistake. So the input we are providing, it is only two. The last one that we are seeing, it's a bias neuron, and you see every layer excluding the output has a bias neuron. So bias neuron is something that is adding a extra boost to the layer, so that if all the inputs are zero, so everything is going to this calculating to this network will be zero, right? So the output will also be zero. So if you multiply zero or everything, whatever the weight is, it doesn't matter, it will be zero. So we are adding a bias to make that zero go away. And this bias neuron won't be considered as the input placeholder nor as a hidden layer matrix. So we will add this bias neuron at the end of the calculation. So what we are going to do is the input will be 2 because we have two neurons, and the this one, so from 2 we are getting 3, from this 2 we are getting 3, so we have 2 row and 3 columns for the weight matrix. To remember this, just whatever there in the left side of the matrix will be our rows, and whatever there is the right side of our matrix will be our columns. That is the best way to remember it. And now we are going to define, we are setting the normal distribution, it's normal random normal initialization. So we are going to define how much deviation there will be from zeros. So we are going to make it std standard deviation, just say point 0. So it will be point 0 from positive side and point 0 from the negative side, like the entire distribution will be centered around 0, and it will go positive point 0 and negative point 0, and it will be distributed like that. So we have initialized the variable weight matrix. Now we want to set the d type, is make it float, and another thing is we want to set the name. Let's say we want to name this layer as a hidden layer. Let's name it hidden. Hidden. Okay, sorry, it should be hidden weights. Now we have the weight matrix. Hidden. Okay, GTDEN. Okay, fine. We have our weight matrix, and we also need to create this bias neurons. Let's create this bias neurons. It will also have